Hi everybody, this video is about equivalent proportions and how you determine if two ratios make a proportion. So let's just review what a proportion is, and if you have this foldable, go ahead and fill it in with me. So proportion is, this is not written on there, so I'm going to write it. A proportion is this, an equation stating that two ratios or rates are equivalent, basically are equal. So we talked about last time, this looks like two fractions, whether or not two fractions are equal to each other. And I'm going to show you three ways to determine if a proportion is equivalent. So basically, by the time you're done with this, you ought to be able to look at two ratios and say, yes, that's a proportion, or no, that's not, and based on whether or not the ratios are equal to each other. All right, so the first way we're going to look at to determine if it's actually a proportion is to compare unit rates. So let's write that down, compare their unit rates. So you can see in this example that they've given you two ratios, 3/21 and 5/35. And really, they say that they're equal, but that's really what we're trying to figure out. Does this actually form a correct proportion? So to get a unit rate, remember you're dividing. So we're going to do same as we've done before, top in, bottom out. So I'm going to divide 21 into 3. Okay, and 21 won't go into 3, so I'm going to add my decimal, move it up, add another 0. 21 will go into 30 once. When I subtract, to borrow, that's going to give me 9. And I'm going to bring down another 0. 21 will go into 90 now, 4 times. 4 times 21 is 84. When I subtract, I'm going to get 6. Bring down another 0. 21 will go into 60 now, 2 times. 2 times 21 is 42. And then again, when I subtract, I'm going to get 18. And I'm going to stop there because I've already gone 3 decimal places. So since I'm comparing these, I'm just going to see if I get the same thing on this side. So again, I'm using top in, bottom out. So top number is 5. 35 is my bottom number. And I can't divide 35 into 5, so I'm going to put a 0 there to remind me of that. And then I'm going to add my decimal and another 0. 35 will go into 50 once. When I subtract, I'm going to get 15, so I need to bring down another 0. 35 will go into 150 and 4 times. 4 times 35 is 140. When I subtract, I get 10. Bring down another 0. 35 will go into 100. 2 times. 2 times 35 is 70. And when I subtract, I get 30. And so if I compare these, I can see that they look to me like they have the same unit rate. So this is 0.142. It's continuing. This is 0.142, also continuing. So I'm going to say yes. This is a proportion. Because when I compared the unit rates, I got the same number. All right, so that's one way to determine if it's a proportion. Another way is to compare cross products. All right, so if we look at the second example, a product is just when you multiply two numbers, two factors together. That's what the answer is called, as a product. And cross products is when you multiply across from each other. So you may have learned this as butterfly, but basically you're going to take the numbers that are diagonal from each other and compare their products. So I want to know if 9 times 35 is the same thing as 45 times 7. So let's look. 9 times 35. 9 times 5 is 45. Carry that forward. 9 times 3 is 27, plus 4 is 31. So it looks like this side is equal to 315. And now if I try 45 times 7, it's 35, carry your 3. 7 times 4 is 28, plus 3 is 31. Also 315. Since these are both equal to each other, then I can, again, say yes. This is a proportion. Because they have equal cross products. That's kind of what defines proportions. All right, and then the third way that you can determine if two ratios form a proportion is by using something called scaling. And scaling is when you either multiply or divide by the same number. So really here, you're trying to figure out if they're equivalent fractions, basically. All right, so what I mean is if I want to change the numerator 3 into a 9, what do I have to multiply to make 3 into 9? I have to multiply by 3. All right, well, if I multiply the numerator by 3, then I'm going to have to do the same thing on the bottom. So is 21 times 3 also equal to 63? And yes, that would be the case. So then I could say, yes, this is a proportion. It also works with division, so I could go backwards. I could say, okay, what do I divide into 9 to make it 3? 3. So 9 divided by 3 is 3. So is 63 divided by 3 equal to 21? And yes, that would also be the case. So again, this is just scaling, another way to determine if two ratios form a proportion. All right, so let's look, I'll do that in later, but let's look and see how you might be questioned about that. So you might see a question like, determine if two ratios form a proportion. So you might start off with like something like 15 over 5 and 3 over 1. And you want to know, does that make a proportion? Well, you can use either of the three ways to decide. So you just kind of pick the one you like. If you like cross products, then try that one. Is 15 times 1 the same thing as 3 times 5? Yep, those are both equal to 15, so yes, this is a proportion. Or maybe you prefer scaling. Maybe you like to do it that way. If that's the case, then you might start off with the same thing, 15 over 5 and 3 over 1. And you could say, all right, in order to make 15 into 3, I had to divide by 5. So is 5 divided by 5 also equal to 1? Yep, that works. Okay, or again, you could do unit rates. So I would divide top and bottom out for both of these. And 5 into 15 is 3, and 1 into 3 is 3. So yeah, they have the same unit rate. So either of these are an acceptable way to determine if it's a proportion. So you don't have to do all three, just choose the one you like. And then let's try one more. If I have 8 over 12 and 16 over 36, and I want to know, do these two ratios make a proportion? So again, I can pick the way I like. If I like cross products, try this. I want to know, is 36 times 8 what that's equal to? So 8 times 6 is 48. Carry my 4. 8 times 3 is 24. Plus 4 is 28. Do the same thing with 16 and 12. 12 times 6 is 12. I'm sorry, 2 times 6 is 12. 2 times 1 is 2 plus 1. Start with a 0. 1 times 6 and 1 times 1. That gives me 192. So I can see that 288 and 192 were not the same thing. So this is not a proportion. Somewhere I want to say that. Okay, because their cross products were different. Or if I had tried maybe scaling on this one, I know that 8 times 2 is 16, but is 12 times 2 equal to 36? No, 12 times 2 is 24. So again, I could have seen by scaling that this was not a proportion. So this should not be an equal sign. You can put a slash through that. It's not a proportion. All right, so again, three ways to determine if two ratios make a proportion. The first one is to compare their unit rates. The second one is to compare their cross products. And then last of all, if you can find a way to multiply or divide the numerator and denominator by the same number, then that could also prove that that's a proportion. So good luck with that, guys.